the charge Q1 experiences a net force of 6.5 newtons. Calculate the magnitude and the nature of Q3. Okay, how do we go about this? Okay, let us go through it very briefly. We have these two charges, Q1 and Q2, coming from interaction between these two. These two charges touched and separated, which means that what we have here for Q1 and for Q2 are quite different from what we have there. So what is our first mission is to establish what these two charges represent. How do you do that? We use the law of conservation of charge. Okay, let's use it and see. Okay, that's the law. What comes next is to substitute. So let's substitute and see what we get. So after substituting, this is what we get. So that one represents the charge for Q1 and the charge of Q2. They are known. Both of them are -2 times 10 power minus 6. Okay. Then what comes next is interpretation. Let's interpret what we have so far. So let us look at this sketch. This is the sketch we are having. So far, because I know the charge of Q1 and Q2, so these are what I have for them. Their signs are clearly known. Now I don't know the sign and I don't know the charge here for Q3. But I know something. I know that because of these two charges and where the net force is going, I'm having that one as one of the forces which created that net force. So this is the component, one of the component of that force. You will have to remember here that the components of the force are on either side of the force and the two components meet at right angle. So this is one of the components which came from that force. Then where is the direction of another component? It is this one. Okay, and that's the direction. Now we have to ask ourselves, if I have a charge here, Q3, and this one is negative, what sign of the charge will create this charge to move upwards? Oh, we have to remember that this charge moving upwards implies repulsion. So which means that the charge I'm having here must have the same sign as that one for repulsion to occur. So now at least I know the nature of the charge. I don't know the magnitude, but I know that the charge here, which is Q3, it is negative. Okay. Then what next? What comes next? Suppose this force, this component of the force is F1, and this component of the force is F2. And don't forget that what I have here is F net. Okay, so having F1, F2, and F net at that angle, what comes into our mind? What comes into our mind is Pythagoras. So what does he say? It says that F net squared is equal to F1 squared plus F2 squared. What is next? Substitution. F net squared is going to be 6.5 squared. F1 is that one up one. F1 is created between this charge and the one I don't know. So I don't have means to calculate it now. But F2 I know. So what is next? I'm going to get my F2. So F2 is made up of these two charges. So using Coulomb's law, this is what we have. Okay, where K is 9 times 10 power 9, and where Q1 is 2 times 10 power minus 6, and the other one is also 2 times 10 power minus 6. This one divided by the intermediate distance, which is 10 centimeters. If we convert it to meters, it becomes 0.1. So from here, I know my F2. I can get it. Let me get it. So this happens to be our F2. So when you go back to Pythagoras, what do we know? We know F net. It is here, 6.5. What else do I know? We know F2. It is here. The only force pending is F1, and it can easily be calculated. So let us calculate F1 after substitution. So after substitution, this is what we get. And let us now rearrange to get F1. So on rearrangement, this is what we get. And let us press the calculator to get F1. So that is our F1. We have to remember that F1 is the force between Q3 and Q1. And it is repulsive, that one we know. So what do we do after getting F1? We apply Coulomb's law, which says that F is equal to KQ1, Q2. For this case, it's going to be Q1, Q3 over R squared. So what do we get out of this one? It's going to be 9 times 10 power 9. Q1 is going to be, we know it, it is 2 times 10 power minus 6. And what we don't know is Q3. But we know the intermediate distance between is going to be 15 divided by 100. You get 0.15 squared. And what you get out of here. So this is what we know. So when you bring in our F or F1, we are going to have this equation 5.41 giving you this. Okay. When you look at that equation, we are going to find out that Q3 is the only unknown. So let us rearrange and get Q3. So after rearrangement, this is what we get. Charge Q3 is 4.51 times 10 power minus 5 coulombs. Yeah, that's it. So it was a marathon, but but it's doable. Yeah, don't forget to subscribe. The channel is PSSB, Physical Sciences Silver Bullet. And it's me, Richard. See you next time. Bye-bye.